Hi everybody, so welcome to your first video made by yours truly, Mr. Nguyen, your Math 7 teacher. So the first video, we're just going to go over some kind of easy that you guys have learned about in 6th grade already, just ratios. So just kind of easing our way in. So ratios, let's think about what ratios are again. I'm going to actually give you guys a couple seconds to even think about that. You guys can pause the video, or I'm going to just be quiet for 5 to 10 seconds. Try to see if you guys remember what a ratio is. All right, so a ratio right here. Here's the definition. You guys should always, have access to the video, so you guys can always just refer back to it when you guys are doing an assignment, or if you need to freshen up your memory on it. Or a good idea is also just take notes on it, write it down, because if you write it down, the more the likelihood that you're going to remember is going to increase. So here, a ratio. A ratio compares. Underline that word because it's important. A ratio compares the value of two different things. It could even be more than two things, but right now we're just going to be learning about a ratio where it compares two different things. So for example, a ratio can compare the number of students who like blue to the number of students who like yellow. For example, if 8 students like blue and 4 students like yellow, you can write the ratio as, let's see, can you guys think about what that ratio would look like? You guys should pause the video. Okay, so a ratio, if you remember, it has 2 dots in the middle. So I guess we'll see how it goes. But for now, if I want you guys to maybe try something out, I'll pause for a couple seconds, and I encourage you guys to also pause the video in case you're still thinking, and I go on to the next part. So a ratio has the 2 dots. So we're comparing, let's see, the kids who like blue to the kids who like yellow. So we're comparing blue to yellow. That means the number of students who like blue has to go first. That's 8. And the number of students who like yellow has to come second. That's 4. And remember, ratio can also be written with the word 2, 8 to 4. So 8 students like blue, and 4 students like yellow. And again, some other ways. This is the most common way to see it. And you can also see it as a fraction as well. So those are all a few different ways to write out a ratio. So moving on with ratio, a really important thing about ratios is being able to write equivalent ratios. So our ratio earlier was 8 to 4, right? And again, some of you guys have remembered this, and it's like really easy. Some of you guys don't really remember it. That's fine. So equivalent ratio. So if I'm given a ratio 8 to 4, to create an equivalent ratio, what we do is we can multiply. I'm gonna write it on the side. We could multiply or divide both numbers by the same number. So the same value, the same number. Remember, value is just a number. Oops, spelled it wrong. Forgot the B. All right. So if I'm given a ratio of 8 to 4, to create an equivalent ratio, what I could do is I can multiply both numbers by any number I want except 0, because 0 would just, remember, you multiply anything by 0, you're just going to get 0. So that doesn't help us there. And also, if I multiply it by 1, does that really do anything? That just gets us the same thing, right? I guess technically it is an equivalent ratio, but it's the same thing. I don't want you guys to ever create an equivalent ratio that's exactly the same number. So we're going to multiply by any number. Let's avoid 0 or 1. You can multiply by 2, or let's just make it a little more complicated, or a little less easy. Multiply both sides by 4, and both values by 4. So 8 times 4 is 32, and 4 times 4 is 16. So that's how you create an equivalent ratio. Let's start with that same ratio, 8 to 4. So back here, what that means is 8 to 4 is equivalent to 36 or 32 to 16. And down here, 8 to 4, if I could remember on the side here, it says you can multiply or divide both sides by the same number. So what I could do here is let's divide by both sides by 2. So 8 divided by 2 is 4. 4 divided by 2 is 2. So here, let me circle all this. All 4 of these ratios are equivalent. Because if you notice, another way, kind of, I guess, better way to think about it is they're equivalent because the value of the second number, isn't that just half of the first number? And same thing over here. This is just half of that number. And all the way down here, isn't 2 half of 4? So in all these cases, the second number is half of the first number. So then that means they're equivalent. Okay, so right here, actually, I didn't realize I have the definition. So I kind of went over how to make equivalent ratios, but here let's just go backwards a little bit of the definition. So an equivalent ratios are when two ratios, that's what, remember what we just had, right? We had a ratio and we created another one. Two ratios that express the same relationship between two things that are being compared. So earlier we had 8 to 4 was a ratio, and we created an equivalent ratio 4 to 2. The key thing, same relationship. That's what I talked about earlier. So you see how that second number is half of that first number? In both cases, that's why they're equivalent. This one's easy because the second number is just half, but sometimes they won't be as clear cut. Sometimes it might be like times 6 or times 6.5. So these two ratios are equivalent because they have the same relationship between the two things. One's half of the other. Or if you think about the first one compared to the second one, the first number is double of the second number, right? So that's what equivalent ratios are. And we just talked about how to create equivalent ratios already. Remember, I'll write it again. By multiplying or dividing both values by the same number. So back to our 8 to 4 ratio example. So just like what we did earlier, we multiplied 8 and 4 by 4. We multiplied both of them by 4 to get an equivalent ratio. Or we divided both of them by 2 to create an equivalent ratio. One thing a lot of students mess up in the past is they'll say, oh, how about I add the same number to both of them? And I get 10 to 6. That does not work. That's not going to create an equivalent ratio. Because here, remember, 4 is half of 8, right? But 6 is not half of 10. So make sure don't add or subtract. That's a big no. So let's look at a couple examples. Oh, well, before we look at an example, let's check to see how we can tell the two ratios are equivalent. So let's look at an example. Let's say we got a ratio 6 to 8, and we got another ratio 24 to 32. On your assignment for today, you guys are going to have to be able to tell if these two ratios are equivalent or not. And you got to make sure you explain why. So I want you guys to think about it real quick. I'll pause the video also. How can we tell if these two ratios are equivalent? So you guys can pause the video. Alright, so hopefully you guys thought about that. If not, you guys just pause the video again. Here's one way. This method doesn't work all the time, but with certain problems it's the easier way to do it. But make sure you know how to do this way and the other way, because this method doesn't work all the time. So if you can make these two ratios have exactly the same numbers by multiplying or dividing, you could tell that means they're equivalent. So if you look over here, what did I do to 6 to get to 24? I can multiply by 4, right? Can I multiply 8 by 4 also to get to the other side? To get to 32? Yeah, 8 times 4 is 32. If you're not sure on that, you guys could always check that with a calculator, or in your planner, I think on page 123 or 132, one of the two. There's a multiplication chart. You guys should always refer to that. I encourage that. So, here, 6, let's see. 6 times 4 gets you 24. 8 times 4 also gets you 32. So therefore, they are equivalent. So check. And you can say they're equivalent because, this part's important. So they are equivalent because I can multiply both values on one ratio by the same number, right? You multiply them both by 4 to get to the other ratio. I'll repeat that. They are equivalent because I can multiply both values from that first ratio by the same number, in this case 4, to get to the second ratio. Again, if that's you're still a little confused, you got to always rewind it a little bit and try to understand it again by hearing it again. Let's think about it the other way around. So it could work backwards also. Remember, it doesn't have to be just multiplying. It could be multiplying or dividing. But remember, it cannot be adding or subtracting. So multiplying or dividing. Think about it. Can I divide 24 by something to get 6? 24 divided by what gets me 6? 4 is that same number. 24 divided by 4 is 6. Everybody agree? Hopefully you guys are at home nodding your heads yes. Same thing over here. Can I do the same thing? Can I divide by 4? Does 32 divided by 4 get me 8? Yeah, it does, right? So again, that's another way you could tell the equivalent, by seeing if you multiply or divide by the same number. Alright, however, this one is not always going to work. I'll give you an example where it doesn't work, where I want you to use the other strategy that will work all the time. Sometimes it's a little more work, but it works all the time. So let's say you came up with a problem and you tried this method and it didn't work. Try this future method that I'm going to talk about right now. So I'm going to give you guys two ratios again, 6 to 8, and then 75 to 100. Are these two ratios equivalent? I want you guys to think about that. Remember, what did we do earlier? Check it, right? Can I multiply 6 by something to get 75? How about think about that? So, some of you guys can already see 6 doesn't go into 75 exactly. You could use a decimal. And remember, a way to kind of tell a shortcut, you could do 75 divided by 6. You guys can use a calculator. I'm using my calculator also. You get 12.5. If I do 75 divided by 6, we get 12.5. What that also means is 6 multiplied by 12.5. Remember, I use the dot right there to show us multiplication. Equals 75. Remember, because multiplication, division is the opposite. I'll repeat that. 75 divided by 6, that gets me 12.5. So 6 times 12.5 gets me 75. Okay, but let's think about that. Why is that important? What am I going to do next? How can I tell they're equivalent? Now, we got to check if it works for the other one also, right? What do I need to multiply 8 by to get 100 to make sure they're equivalent? So I could do 8. Well, we're supposed to see if they're equivalent. It has to use the same number here, right? So we'll do 8 times 12.5. So what is 8 times 12.5 get us? I get just 100. Right? So they are equivalent. Because we multiply both numbers, or both numbers of the ratio right here, 6 and 8, by the same number, 12.5, to get me to the other ratio. However, that's pretty complicated. You would need to use a calculator, and you can't just look at it. Most of you guys can't just look at it and say, "Oh, I know that 6 times 12.5 will get me 75." So if that doesn't work, again, it worked in this case, but it's dealing with decimals and makes it a little bit harder. So let's talk about that other way now, that I think will be easier a lot of times. You got 6 and 8 as one ratio, and 75, 100 as the other ratio. Let's think about, we want to simplify it. You guys have learned simplifying in the past. So how can I simplify this ratio? How can I make this ratio smaller? What can I divide both numbers by? What goes into 6 and 8? Hopefully you guys are thinking in your head 2 right now. Yeah, 2 goes in both of these numbers. What's 6 divided by 2? That gets us 3. 8 divided by 2 gets us 4. So one way to tell two ratios are equivalent, also, I like this method better sometimes, is making the ratio into an equivalent one that's as small as possible. Right here, it's as small as possible because can anything go into 3 and 4? Nothing except 1, right? So that's the ratio in its simplest form. Let's think about now on this side. I want you guys to think about, what can I divide both these numbers by? So what number goes into 75 and 100? Some of you guys might be saying 5. Yeah, you could do that. But I want you guys to always get in the habit of trying to figure out what's the biggest number. So if I did 5, I get 15 to 20, right? Is there another number that still goes in 5, 15, and 20? Yeah, 5 goes into both of them, right? So let's go back. Let's try to think about what's the biggest number that goes into 75 and 100. You guys remember counting by 25s? 25, 50, 75, 100, right? So here, 75 divided by 25 is 3. Let me change that to 3. And 100 divided by 25 is 4. See, I see how these ratios are equivalent, right? Because we simplified both of them by dividing them both by the biggest number that can go to both ratios. In this case, 2. In this case, 25. We simplified the ratios. And you see, they're basically the same. That means they're equivalent ratios. Alright, we're going to finish off with one last word problem as practice. I want to make sure you guys are able to do the assignment. So I want to give you guys a practice round that's similar to it. So here, let's say In Mr. Noonan's class, there were 10 boys and 15 girls. In Mr. Ricklick's class, in his small class, there are only 2 boys and 3 girls. Are the ratio of boys to girls the same in both classes? Explain and show your work. You guys can pause the video if you guys want to try doing your own. I encourage that. But right here, we'll just start. So in Mr. Noonan's class, let's do Mr. N and Mr. R for the other side. So there are 10 boys to 15 girls, right? In Mr. Ricklick's class, there's 2 boys to 3 girls. So how do we tell if they're equivalent? Let's think about what we just did. Can I make this ratio here more simple? What can I divide both of them by? What goes into 10 and 15? 5. So 10 divided by 5 is 2. 15 divided by 5 is 3. So I just made that ratio for Mr. Noonan, for me, more simple to work with that one. And guess what? Look what you see. It's the same ratio as over there for Mr. Ricklick, right? Therefore, already you could tell they're equivalent. Remember, here I can't do anything else with this one. Nothing can go into 2 and 3 besides for 1. And we don't really mess with 1 because 1 doesn't really help us. So we can tell they're equivalent. I won't write it out, but I'll just say it. Both ratios are equivalent because I can simplify the first ratio to make it the same as the second ratio, right? This ratio 10 to 15, I made it so it's the same as for Mr. Ricklick's ratio. That's one method. I'm gonna quickly go over the other method. Think about over here. How can I, remember, the other way is, can you go from here to here by multiplying by the same number? 2, how do I go from 2 to 10? I can multiply by 5, right? How do I go from 3 to 15? I can also multiply by 5. So you see how we multiply both numbers by the same number to get the other ratio. So in your explanation, if you did it this way, you can say both ratios are the same because for the ratio for Mr. Ricklick, I can multiply both values by 5 to get the same ratio as for Mr. Noonan. Hopefully that's helpful. It went a little longer than I would hope, but the more information, the better. Good luck on the assignment. You guys always email me on Google Classroom or post a comment or question on that website, Google Classroom as well, if you have any questions. All right, good luck on that.